The next objective in this section is to be able to solve literal equations for a specified variable. Another name for a literal equation is a formula. So basically we want to be able to manipulate formulas such as this one for distance equals rate times time for uniform motion problems. Perhaps what we know in this type of relationship is we know the distance. We know how long it took us to get there. What is the rate? Maybe that's what we want to know, is what is the rate? So we want to solve this literal equation, and it will say for a specified variable for r, for example. This is r times t, so how to get the t off of there is divide both sides by t. And so to solve this for r, distance divided by time will give you the rate of an object moving in a uniform motion. Or if you want to say rate is equal to distance divided by time, you can do that. Either one of these two answers is your literal equation above. Solve for r. Let's look at a few more examples. Here they give us some literal equations, and they want us to solve for the specified variable. In this case, we have E equals I times R. They want us to solve for R, so just like on the last page, we're going to divide both sides by I to get R on a side by itself. That way the I's reduce, leaving us with E divided by I is equal to R. That's our answer. Over here, 7x minus 2y equals 5. We want to solve that for y. We want to get y by itself. Anytime this is a negative, I would really like to go ahead and add 2y to both sides and then subtract 5 from both sides. You'll see why. That way we have 7x minus 5 equals 2y, and we're solving for y, so we're going to divide both sides by a positive 2. And it just looks prettier to divide by a positive whenever you possibly can. So we solved this for y, and we got y equals 7x minus 5 all over 2. Okay? Down below, we're going to solve this equation for A. So the first thing I think we should do is go ahead and get the n over 2 off of this side by multiplying both sides by n over 2's reciprocal, 2 over n. Hey, why not? We can do that when we multiply both sides by any non-zero quantity. So over here on the left-hand side, we have 2s over n. Now on the right-hand side, we just have 1 times the stuff in the brackets, which is just going to be the stuff in the brackets. 2a plus quantity n minus 1 times d. We're trying to get a by itself, so let's move this term to the other side. We're going to subtract quantity n minus 1 times d from both sides. That'll give us 2s over n minus quantity n minus 1 times d equals 2 times a. Now the last thing we need to do is divide both sides by 2. Divide each term by 2, or an option to dividing by 2 is multiplying by a half. Here I'm going to write divided by 2. For this term, I'm going to write divided by 2. I don't want to create a complex fraction here, so we do know that dividing by 2 is the same thing as multiplying by a half, so that's completely legal. Now, what we have is, once we reduce the 2's here, we have s over n, because the 2's reduced, minus quantity n minus 1 times d. That term is divided by 2. That is equal to A. And so we solve that formula for A. I think I'll put the next example in a separate video since it's a little bit long.